Hi, my name is Amritpal Singh. I am a general physician from India. I attended NMA Academy last year as a doctor, and this year I will be teaching as a TA. So today in day one, week one, day three, tutorial four, we will be learning about multiple linear regression and polynomial regression. So we will begin by simulating some data, then training on the models, and finally comparing them. Right. So importing these functions. And then coming to multiple linear regression. So what is we have an equation of y here, which is represented by this mathematical equation where eta represents the noise, theta naught represents our bias term, and these x's are multiplied by their respective model parameters. Now, looking at the same thing in form of metrics, we see here that we have all the different x parameters, and this one is used for the bias, and on the multiplication, the matrix multiplication, we will get a y term. So we use we simulate some data here. Finally, given x and y, how would we calculate theta, right? So we do so by something known as ordinary least square estimator, which we have discussed earlier. Now, coming to the formula, if in this function we will take x and y and give an output of a theta hat. To do so, we do this by this function where we use matrix multiplication and then matrix inversion and transpose function, right? And then this is the output theta hat we get, which can be used later on to calculate our mean square error, right? Now, looking at the this data, we will be seeing that the data is linear, and these distances which we see are the distances from the plane, which tells us the error. The more the distance, the more the error. Coming to the polynomial regression, it's similar to multiple linear regression in several contexts. One significant difference being that the x here is in more than one powers, and can be of power 2, 3, or any power. And the highest power is what we call as the order of polynomial. So, how simulating the data here? How do we, uh, train a polynomial regression model? This would be done by using a design matrix, which helps us inputting the data into the model. Now, to generate a design matrix, we will use this function here, and take the x input variable inside and define the order of the model which we want to use. And if I just Yeah. So running this, we will be getting our design metrics here. Now we will use this to train our polynomial regression model in this function. So in what we will be doing in this function is taking the x and y, and we will be defining our max order. So we will be training multiple models here, starting with order 0 till the max order which we will define, which will be 5 in this case, right? Now we will be first of all generating the design matrix for all, uh, then generate the theta, and we will be running this thing in a loop so that to train all the models. And then when I finally run this, I will be seeing a graph like this, where we can see different orders and their polynomial fits. Now, to compare these models, we will be calculating their mean square errors, and for that, in this function, we will be first of all calculating the prediction of the model, then the difference in the model, in the prediction and the actual value, and finally using it to calculate the mean square error, and then uncommenting this. And if I finally plot this, I will be seeing a graph like this. Uh, as we see that generally the higher the order, the lower the error. So yeah, that's it for this tutorial. Spend some more time with the code, and play with the code. uh, See you in the next lecture. Thank you.